So here is my new distance sensor. I couldn't afford really sensors for little Gilligan over here. So here's what I built. This is the theory on a modulated 38 kilohertz signal, and you can judge distance with it. You basically have two LEDs, a 38 kilohertz 3-pin sensor, a couple transistors, a Pickaxe 08M generating the signals, the wavies, a little trimmer pot here, which actually turned out to need to be a value about like 2 ohms, 3 ohms, so kind of get the smallest one. This one's a 1K, and I have like 1 turn left before I max it out. And then the associated resistors for the transistors. Here's the circuit. These two transistors have a current limiting resistor on them in real life, but nevertheless, you've got here's the trimmer here, and someone please correct me if this transistor it's kind of on the wrong side of the load for an NPN, I think. I'm not an electronics person, so if this is wrong, someone tell me. It works, but alright, so here's the trimmer with basically main power coming in. That adjusts the brightness of the LEDs and thus the distance. This transistor is clicking these on at the 38 kilohertz, and then this guy at 1000 hertz is basically, you're getting 38 kilohertz bursts 1,000 times a second with this setup. Here's the sensor. Oh, this 1000 kilohertz, the 38 kilohertz is coming from the pulse wave modulated output of the Pickaxe. I just dialed in 38,000. And then this guy is coming from a single high command and 2 low commands. And that's it. That's all it's in the loop. Main, high, low, go to main. And between those 3 commands, the amount of time it takes to execute those commands creates this 1000 hertz. And it's kind of close, but it works. So, skip it. Sensor, supply, and then here's a 10K resistor and a cap for a DAC converter, so it's not so spiky coming in. So, and then there's the ADC going out. So here is version 1. This was a total fail. I thought that I didn't need any transistors because I figured, oh, it'll just be high and it'll be fine. But no, because that's going high-low and that's going high-low, there's a point at which it's going backwards and then the LEDs blow up. So that one, no good. Okay, and then this is version 2. This one worked great on a scope, but it was really spiky still, and the ADC wouldn't read it. The ADC read highs and lows funny. So so I had to smooth that out. So I tried this guy on a breadboard with the resistor cap set up as the digital analog converter, and that worked. So I ended up with basically this same board, but now in this form, with little paint, so it's pretty and clean and nice mounting holes, and the cap resistor set up on board. So I will show you how this works. What I have done, this guy is it's very, very simple. It just spits out an analog value. It's high, it's 1023 when it's seeing infinity, and that value decreases getting closer. So I've got a speaker here to we're basically just read ADC and then tone out with that value. So you can hear the distances here. So I'm going to set you down for a second here, dear viewer. Alright, so we are now plugged in, and in a second, let's see what we got here. There's my first click. Well, I'll just show you first. So here's this. Let's see if I can scoot back far enough. Is there a dog behind me? Okay, here we go. Oh, you know what? I'll use this. I have a target. Okay, here we go. And you can hear it kind of woo, 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 woo. I think with a better DA converter, it would probably be less woo, woo, woo-y, and you could get a smoother out. But for a little hobby robot, this is plenty of, you know, what you just do like 3 steps, like nothing there, something there, maybe start thinking about turning, and too close, you know. Yeah, and then I'll show you one more. I've got this trimmer pot here, and this is really slick because this is distance. So to zero it, you basically max it out until it self-triggers right there. Okay, and then you turn it back until it just barely stops self-triggering. Right there. A little more. There. And now we're calibrated. And it's pretty quick too. So there you go. 38 kilohertz sensor. And total price. Probably, if you were to get it online, I bet you could build this entire thing for $7 and a chunk of whatever board you happen to have lying around. If you buy everything from Radio Shack except for the chip, I still think you're under 15 bucks, maybe 10 or 12. You're surely going to have some transistors and resistors lying around, probably have the cap lying around. 08M is like 3 or 4 bucks. The sensor is just a buck or two. Trimmer is a buck or two. And that's it. Ting. It works.